In this video, we're going to talk about equations of proportional relationships. We've already looked at what proportional relationships look like in tables, what they look like in graphs, and now we're going to add the final piece to this is equations. So what does the equation of a proportional relationship look like? How do you write an equation of a proportional relationship? And how do you use an equation of a proportional relationship to solve problems? So let's take a look back at some tables of proportional relationships we've seen before. So we're going to look at the tables and notice how the constant rate of change, that unit rate, relates to the values. So again, this goes back to that unit rate. The unit rate is really a critical piece in any proportional relationship. That's the key thing that we keep talking about. So it is important. We see it in the table, we see it in the graph, and we're going to see here in a minute that we're going to see it in the equation as well. So finding the unit rate first is critical. So looking at Evan's savings, we can see that this is a proportional relationship because every one of these ratios is equivalent and it has a constant unit rate. These are always $20 per week. So Evan is always saving $20 per week in every one of those ratios. So how do we relate the number of weeks to the number of dollars that Evan has saved? How could we figure out how much Evan has saved for any number of weeks? So what if Evan had saved his money for 10 weeks? How would we figure that out? How would we figure out how much money he has saved for any number of weeks? Well, since Evan is saving a constant rate of $20 per week, all we would have to do is take 20 times the number of weeks to figure out how many dollars he's saved. So we could come up with an equation here that dollars is equal to 20 times the number of weeks that Evan has been saving. And here weeks is our independent variable, so that's the x value that's going to go on the x-axis, and dollars is the dependent variable that's going to go on the y-axis. So we could say that y is equal to 20 times x. And there we've already written an equation, and we're going to see that that's what the equation looks like. So you can see that the number in the equation here is that constant rate. It's that unit rate. So it appears in the equation as well. Let's look at this proportional relationship where the number of tickets and the cost is related. And again, this table shows a constant rate of $3 per ticket. So how could we find the cost of any number of tickets? Well, we would take the number of tickets, x, times 3. That would tell us the cost. So the cost of any number of tickets would be 3 times the number of tickets that we buy. And since we don't like to write out words in our equations, we're going to say cost is our y value. It's the dependent variable. And we're going to take 3 times tickets, which is our independent variable, or x. So here is the equation for that relationship. The number, or the cost, is equal to 3 times the number of tickets, since 3 is our constant rate. And that's going to be true for any proportional relationship. Every proportional relationship is going to follow that format, and here is the format. For any proportional relationship, the equation will look like this. It's always going to be the dependent variable is equal to the unit rate times the independent variable. And that's a lot of words there, so we kind of abbreviate that in math. Our dependent variable is the y value, and we're going to call that unit rate k. So k, think k as in constant. We're not going to use a c here because in math c means something else. So they use a k because it makes the constant sound. So it's the constant unit rate, so k times the independent variable x. So every proportional relationship will always look like this. The dependent variable is equal to the unit rate times the independent variable. That's another way to look at it too. Okay, so let's apply that here. How do we write an equation for a proportional relationship? So the first thing we want to do is identify those independent and dependent variables. We've been doing that in tables, we've been doing it in graphs, and we're going to do it again in equations. The next thing is to identify the constant rate of change. Does that sound familiar? We do that a lot. We have to know what the constant rate of change is in order to determine what our value is going to be in our equation. And remember, that is always the dependent variable divided by the independent variable. And then we're going to use that constant rate of change, or that unit rate, to write the equation in this form: y equals k times x. Y equals k times x. So here, the cost of pizza is proportional to the number of pizzas you buy. So that tells us we already have a proportional relationship. The cost of different amounts of pizza is shown in the table. We want to write an equation that can be used to find the cost for any number of pizzas. So here, the table is only as good as the number of values in it. So this only tells us what 1, 2, 3, and 4 pizzas cost. An equation, however, would help us find the cost for any number of pizzas we would want to calculate. So we're going to turn this table into an equation. So the first thing we need to do is identify the independent and dependent variables. Well, the cost is dependent on how many pizzas we buy. So the number of pizzas is our independent variable. This is our X value. And the cost is our dependent variable, which is our Y value. So number of pizzas is the independent variable, and the cost is the dependent variable. So what is the constant rate of change? That unit rate, again, that's the dependent variable divided by the independent variable. So I can pick any one of these because they're all going to be the same and divide them. I'm going to pick the easiest one here, and that's going to be $10 for one pizza. So that is $10 per pizza. And you can check all the other values too. They're all going to be the same unit rate of $10 per pizza. So now I know the constant rate. So use that to write an equation in the form of y equals k times x. So y is going to be 10 times x. So the cost is going to equal 10 times the number of pizzas that I buy. So how would I use that to figure out how much 9 pizzas would cost? Well, I'm going to write my equation. Y equals 10 times x, and x is the number of pizzas. So I'm going to replace that with how many pizzas we're going to buy, 9. And 10 times 9 is 90. So the cost is going to be 90 or $90. So it's going to cost me $90 to buy 9 pizzas. So now we can use this equation to find out how much it costs for any number of pizzas that I want to buy, which is a pretty powerful tool to have because tables and graphs are kind of limited. They only show the amount that you make them out to be. Next one, the water level in a children's pool is proportional to the amount of time it is being filled. So write an equation that can be used to find the water level for any number of minutes. So here we have the water level at 5 minutes, 7 minutes, 9 minutes, and 11 minutes. And we want to find an equation that we can use to figure out the water level for any number of minutes. So the first thing we need to do is identify the independent and dependent variables. And again, the level of the water depends on how long the water has been filling. So time is independent, water level is dependent. So the time is our independent variable, water level is the dependent variable. What's the constant rate of change? That is our dependent variable divided by the independent variable. So if you take 21 divided by 5, I'll just take that first one there, 21.5 divided by 5, that's going to give us 4.3 gallons per minute. So this pool is being filled at 4.3 gallons per minute. That's my unit rate. Now I can use that unit rate right there to write an equation. So the water level is going to equal 4.3 times the number of minutes that it has been filled. So how many gallons would be in the pool after 18 minutes? So I can use my newly written equation. 4.3 times x. And since I know my minutes, I can take 4.3 times 18 to figure that out. And 4.3 times 18 is 77.4 gallons. So after 18 minutes, we're going to have 77.4 gallons in the pool. So now let's look at a graph and see if we can write an equation from a graph. Keith plants a seed. Every 3 days after the seed sprouts, he measures the height of the plant. The graph shows the results. Write an equation that could be used to find the height of the plant for any number of days. So identify the independent and dependent variables. This is easy to do on a graph because the independent variable is always on the x-axis. So days is our independent variable, and the dependent variable is always on the y-axis. So the height of the plant is our dependent variable. And then what's the constant rate of change? That's the dependent variable divided by the independent variable. So I can pick any of these values on the line. 6 divided by 3. 6 divided by 3 is 2. That's 2 millimeters per day. So my plant is growing at 2 millimeters per, 2 millimeters per day. So now I can write an equation with that unit rate. Y equals 2 times X. And I can use that equation then to find the height of the plant after 15 days. X is days, so 2 times 15. Y equals 30, and that's millimeters. The height of the plant after 15 days would be 30 millimeters. Here we just have a description, so we don't have a table and we don't have a graph, but we can still write an equation. A factory can produce 57 bikes every 3 hours at a constant rate. So that tells me that is proportional. Write an equation that can be used to find the number of bikes the factory can produce for any number of hours. So again, identify the independent and dependent variables here. So we have bikes and we have hours. So the number of bikes the factory produces depends on how many hours they've been producing it. So hours is our independent variable, and the number of bikes produced is the dependent variable. So what is the constant rate of change? Again, that is our dependent variable divided by the independent variable. So that's number of bikes divided by the number of hours, and that's the only piece of data we have. And 57 divided by 3 is 19 bikes per hour. 19 bikes per hour. I can use that constant rate, that unit rate, to write my equation. Hopefully this is getting a little repetitive because it's the same procedure over and over again, regardless of whether we have a table, a graph, or just a description. And so this equation right here can be used to figure out the number of bikes for any number of hours. So how many bikes does the factory produce in a 40-hour week? So bikes equals 19 times the number of hours, which would be 40, and 19 times 40 is 760. So this factory could produce 760 bikes in 40 hours. So there we can see we can use that constant rate, that unit rate that appears over and over again in proportional relationships, to write an equation in the form of y equals k times x from a table, from a graph, or from a description of a proportional relationship.